Hey guys, welcome back. So this video is part two of our transformer action. The first one we looked at was what was happening at no load. So things where we had that small current flowing, that exciting current, that magnetic field that was producing the lines of magnetic flux that we called the exciting flux. We had that counter EMF that was actually limiting current to that small value on the primary side. And it's going to stay at that value because we have no load, we have no change. We have no load on the secondary side. That current's just going to stay at that fixed value. There is no change. The magnetic field induces a voltage on the secondary winding. That's where we could take a voltmeter, go across those terminals and see what that voltage actually is. So now let's look at what happens when I add load to this circuit. Okay, so I have, let's say we added a nice big red light bulb to that circuit, okay? So we had a voltage that was induced onto this secondary side. And it's going to be an AC voltage because this is an AC source and DC transformers don't work that well. So I have a voltage, I have a load, I have a path, I have a viable electrical circuit. So I'm going to have some current that starts to flow based on the load. So this current is going to be my load current. Well, that current is going to flow through my light bulb. Light bulb glows nice and bright. Fantastic. That current, when it enters this coil, we have a magnetic field around this conductor because of this load current. So that current that is flowing through my secondary winding, this is still an AC circuit. That current of my load is going to be expanding and contracting with the voltage. Okay, so that expanding and contracting magnetic field that is on this conductor, okay, that has a magnetic field. Well, I have relative motion between a conductor and a magnetic field again. Okay, so with that relative motion, I will have another counter EMF that is produced based on that secondary current. So how does this relate to the source? Well, this counter EMF from the load current is going to be an opposite to the counter EMF and that magnetic field that was established from the source. So I have relative motion between a conductor and a magnetic field. This magnetic field from the load is putting a magnetic field onto the core of this transformer that is going to subtract from the magnetic field of that source. So if we remember, that magnetic field, that counter EMF that was existing from the source was what was limiting current on the primary side. So if I reduce that magnetic field, if I reduce that counter EMF, I'm going to have an increase in current on the primary side as well. So this is how we get that increase of current on the secondary side, and we see it's directly proportional to the increase of current on the secondary side. Why? Because the magnetic field is also directly proportional to that current. So if I had an increased current on the secondary side, I will also have an increased current on the primary side. And it's always directly proportional. If I double the load on the secondary side, the current on the primary side will do the same. So I hope this has helped. We'll see you in the next one.